Can go ahead and get started. Hello, everyone. Thank you for joining us today. We are recording the presentation and we'll send it out along with a copy of the slides to everyone afterwards. If you have any questions during the presentation, you can put them in the chat box and we will answer them at the end. I'd like to introduce our speaker today, Chris Thompson, Analytical Senior Scientist at Whirl-Pak, who will be talking through his relatable experience and his initiative of operational improvements to their bioprocessing procedures. Take it away, Chris.
Actually, I think Kristen's going to go first, just to introduce Whirl-Pak.
Yep, just quick introduction. I'm marketing director with Whirl-Pak, and we actually teamed up with Chris Thompson. As he walks you through his story, you'll see that part of that story is Whirl-Pak. And so just Whirl-Pak and our sterile bags are on your pathway to success for some sustainable solutions. Off to you, Chris. Thank you.
Absolutely. So my name's Chris. I'm a senior scientist with Herbalife Nutrition. We partnered here with Whirl-Pak to present kind of an overview of a methodology change at Herbalife Microlaboratories and how that change led us to cost savings and plastic use reduction. So Kristen introduced Whirl-Pak, but Herbalife, that's me. We've been an industry leader for the last 40 years in nutrition and dietary supplements. And we've been dedicated to making the world happier and healthier through nutrition. This webinar is structured in 5 sections. The middle section is going to be comparatively quick, while 1 and 5 are a lot more substance. In the first section, I'm going to be talking about Herbalife's pathogen testing requirements and why we started this journey of incorporating an entirely new method in our laboratories. You're also going to learn about how we wanted to streamline our testing by developing a universal method, our need to move to a small format, a high specificity test, and our want to reduce testing costs. We wanted also to reduce plastic waste, and we had to do all of that while maintaining regulatory requirements. In our second section, you'll learn about Herbalife's approach to establishing industry partners for the development of new methods. They had to fit a strict criteria for method development. They had to demonstrate the ability to provide the assay according to agreed upon expectations. With specifications, they had to fit AOAC PTM guidelines for validation, and they had to be able to do it in under a year. And you're also going to learn why we decided to collaborate, in this case, with bioMérieux. I'll take you into how Herbalife took an assay that bioMérieux developed and ran it through a small battery of tests to verify that it worked in laboratory situations. It was kind of imperative to ensure that the assay would work as it was intended to, and if necessary, learn about anything that we would need to change, anything regarding laboratory conditions, methodology, equipment, and training. We used modified AOAC developer validation guidance for our internal verification. And we challenged the assay with a specificity study, a matrix study, looking at the limit of detection, and a robustness study. Fourth, you're going to learn about how we implemented this new method, including some of the challenges that we had with rollout that we had to overcome. You're also going to learn about the real cost savings that Herbalife has witnessed in implementation, including the cost savings on media, consumables, and hands-on time. And I'm also going to discuss the differences in specificity. And finally, I want to finish with our plastic savings, including the purchased plastic reduction, waste reduction, our use of Whirl-Pak bags, and the challenges with Whirl-Pak bags that worked, and our effect on environmental impact. Jumping right into an Herbalife introduction, we are a global nutrition company. We sell products in more than 90 countries worldwide, manufacturing sites in Lake Forest, California, where I am, Winston-Salem, North Carolina. In China, we have Nanjing, Suzhou, and Changsha. Last year, we had a manufacturing in Virginia. All sites currently have their own pathogen testing methods, but no 2 sites have the same pathogen testing methods. And in investigations, where alternate sites need to confirm results from one site, it can lead to inconclusive answers or inconclusive results and conflicting answers. If one methodology has a higher sensitivity, it can find a potential pathogen in a method where another method cannot. One of my duties as a scientist for this organization is to, So one of my duties as a scientist for this organization is to develop micro methods, including pathogen testing, quality indicators, environmental monitoring, and investigatory response. A challenge would be to harmonize these methods worldwide, especially on both coasts of the US and China. We noticed that we had the potential for conflicting results, and to harmonize our methodology for pathogen testing, we would need something entirely new for both US and China. We explored our needs for a new method, and it looked like this. We wanted to streamline our raw material and finished product testing by the use of a universal method. We wanted to transition to small format, reducing space needed for equipment, kits, consumable storage. We needed to improve specificity to reduce the amount of false positives. One of the most important factors that was an easy sell to the finance guys was the cost savings potential in a new pathogen testing format. And in addition to those costs, we wanted to reduce plastic waste as part of our green initiatives. And we had to do it all while maintaining our regulatory requirements. The first want was to standardize a workflow for all of our finished product matrices. Our methodology would require different approaches to many of our different products, and we make over 760 of them in the United States. These include dietary supplements in powder, tablets, and capsules. We also produce sports nutrition products like protein shakes, workout aids, and hydration supplements. Our main product line is a meal replacement shake. Some products will require FDA BAM methods, traditional biochemical methods, plate and tube media. Some products will require pH neutralization. The pH was tough. In the case of our, like in the case of our lift-off effervescent tablets, we wanted to streamline our methodology so that we could treat all of our products the same way without having to make adjustments on a product-to-product basis. Included in that is our need to streamline our raw materials as well. We test every raw material that comes into our manufacturing sites, and this includes huge volume raw materials like protein sources, soy protein, whey protein. It also includes large volume sweeteners like fructose. We get vitamin mineral premixes, natural and artificial flavors, botanicals. And those ingredients all prove challenging for one standard method, as many provide color interference or fluorescent interference, preventing us from using a lot of different platforms on any given raw material. Our second want was to move to a small format. So in combination with harmonizing the workflow for all those raw materials and finished goods, we wanted to move to a small format. In this sense, that means PCR. We have a small laboratory, and so equipment footprint and room temperature, fridge and freezer storage space is very, very limited. Pushing out a harmonized method to all the laboratories would require us to remain as small, physically small as possible, limiting the constraints that restricted laboratory space puts on us. In PCR, equipment, reagent, kits, and consumables are all smaller than traditional biochemical methods. It also allows us to do more with single equipment, because one RT-PCR can do pathogen detection like what we want here, but it can also do botanical identification, GMO quantitation if you're into that, allergen quantitation. Multiple purpose equipment like that are kind of a necessity in small laboratories that continuously add responsibilities with space restrictions that remain constant. Movement to PCR also kind of gets us to a higher specificity and a small format. PCR-based detection of pathogens is more specific than traditional biochemical methods. Combined primers and probes provides exclusivity that we didn't have before, and it removes groups that we don't deem risks for our products that might share the similar biochemical profile to those that we're concerned about. Molecular detection mechanisms also provide sensitivity improvements over biochemical tests, where instead of the detection limit being like one viable cell that grows into a colony, for example, We only need amplifiable strands of DNA or RNA. With our commitment to quality, the assurance that we have the smallest detection limit available is a necessity to release quality products. Our third want in revising our pathogen testing methodology was to decrease our cost. We weren't seeing a consistent negative slope on our 12-month pathogen testing average. Our practiced average over 2 years was higher than our theoretical average by 87%. This is a big overage in testing cost, due in most part to us being investigative center for other laboratories that had presumptive positives, and our own laboratory having presumptive positives that needed confirmations. We wanted to bring that total cost per sample down as much as possible. Using small format RT-PCR, we could move to a universal method. We could use a single enrichment, reduce the costs of sterilware and kits, and drive down those testing costs. And we all wanted to do all this using less plastic. This coincided with our green initiatives to reduce our organic and inorganic waste. We are still using a lot of single-use sterilware for nearly every step of our methodology. Single-use sterilware for 3 methods is 3 times the amount that we have to do for 1 method. The biggest single-use plastic in this case was a 500 milliliter polycarbonate bottle, a screw cap bottle, which weighs 108.3 grams. And this is about 81% of the plastic on a per sample basis we used in our testing. We wanted to reduce all of this plastic purchased by potentially using a totally different new methodology, new enrichment strategy. And these were all secondary to our need, and that's we needed to maintain regulatory compliance. We adhere strictly to 21 CFR. Our laboratories are ISO 17025 certified, and that means that any method that we incorporate has to be fit for purpose and scientifically valid. We use 21 CFR to deem our pathogen risk, and those risks that we deem are E. coli, generic, Staph aureus, and Salmonella. We used all of this information to propose to industry partners a scientifically valid RT-PCR method for the detection of these 3 pathogens using a single enrichment, and we wanted to be easier and reduce our costs. Proposing that kind of want to the industry raised some heads. This kind of a multiplex PCR could be extremely useful to the dietary supplement nutraceutical industries, whose matrices are a lot like Herbalife's, very, very challenging. We had to find potential partners in the method with us, and those potential partners had to demonstrate their ability to produce results. Once we found a partner that demonstrated that they could do this, we had to agree on those expectations, including assay specs, validation requirements, and time frame. We reached out to 4 potential industry partners and molecular development leaders, and they all had relevant assay development experience. They all had the ability to multiplex 3 pathogens together in a specific and sensitive test method. We approached those who we thought had the ability to validate it according to an AOAC guideline, and those who were able to provide future kits at a lower cost than we were currently spending on 3 pathogen testing kits. We considered performing it in-house as well. All of our partners were compared in their ability to develop, validate, and manufacture a molecular assay that met both of our wants and our need. 3 of those 4 were able to lower our costs. 2 of those 3 were able to validate according to AOAC guidance. Both of them had significant experience in food and dietary supplements. We'd seen their publications in AOAC PTM publications. And we agreed that we approached both of those remaining candidates with assay specs. And specifically, the tough one was fractional recovery in 25 grams of sample. The specific detection of generic E. coli, Staph aureus, and Salmonella was challenging. And they had to have the ability to fulfill orders for all Herbalife US manufacturing with potential future rollout to China laboratories. The assay also had to meet strict validation requirements, those laid out by the AOAC method developer guidance. and it must pass independent verification at Herbalife Microlabs. They all had to do it in 1 year. And in the end, we collaborated with bioMérieux because they had previously demonstrated their ability to produce accurate molecular assays, even when multiplexed. We looked into their validation of the EnviroPro assay, which multiplexes Listeria species and Salmonella species. They had also worked with complex dietary supplements, even demonstrating to us that the VeriFlow assay for challenging dietary supplements worked. And most importantly, bioMérieux had previously shown dedication to Herbalife by providing personal service to us when demonstrating both of these previously mentioned assays. Section 3. After bioMérieux passed us their tech transfer package, we received their Nutriplex Pro kits in our freezer. We had to take their procedure and verify that it worked in our laboratory. We did this by performing a small verification study by challenging the assay's specificity, the limit of detection in matrix, and robustness. I'm going to gloss over the methodology for those challenges and the results here. We challenged the specificity of the method by testing its inclusivity and its exclusivity. The method had to detect inocula of the enrichment broth of our control strains of E. coli, staph, and Salmonella aveni. If it did this, it passed our resource-limited inclusivity tests. We don't have the 30 type strains that you need to do an AOAC PTM inclusivity test. As an exclusivity test, we tested the method with 6 different Enterobacter that were not E. coli or Salmonella. We also tested the method against 3 strains of firmicutes that were not Staph aureus. For inclusivity, we inoculated 450 milliliters of enrichment broth with less than 100 CFUs of the 3 challenge organisms, so we have a low-level inocula. And we proceeded to enrich and follow the provided procedure for the Nutriplex Pro assay. These results had to be detected, which is our passing criterion. For the exclusivity tests, we inoculated 450 milliliters of enrichment broth with more than 10,000 CFUs, so a high inocula of non-target organism, and moved that enrichment through the procedure. These results had to be not detected. We chose to inoculate less for inclusivity and more for exclusivity to further challenge the enrichment capabilities in the assay under high-load, non-specific organism. We performed a matrix study and tested the limit of detection of the method. In matrix, we had to see 3 conditions met: the detection of target organisms with low-level inocula in matrix, the detection of organisms with high-level inocula to ensure that resources aren't taken up, and the detection of target organisms with low-level inocula in a competitive co-enrichment with Salmonella. We had to perform the competitive enrichment to challenge the method to ensure that a low-level staph, for example, would still be detected in a high level of a faster-growing microorganism like Salmonella. We created pseudo-samples by using 8 matrices, including multiple finished goods and raw materials. We inoculated those pseudo-samples in enrichment broth with either on the low level, 100 CFUs of target, or on the high level, greater than 10,000 CFUs of target, and all had to be detected. Our robustness study was really easy. We tested the repeatability of the method with changing non-critical variables, which was things like lot-to-lot variation, personnel, different laboratories, different equipment. We challenged the inclusivity test in triplicate with 3 lots of assay kits, 3 lots of enrichment media, 3 lots of the lysis kit that you use, and 2 analysts in 2 different locations. All results had to be detected to meet acceptance criteria. And they were. They passed flying colors. So we decided to roll it out. After it passed our acceptance criteria for internal verification, we were able to sign off on the method and roll it out after training our analysts. Here, I'm going to explain some of the challenges that we faced with that rollout, how we overcame them. I'll also share with you the real cost savings that we see. in media, consumables, and hands-on time. I'm going to go over the real increased specificity numbers. We rolled this assay out on June 30th of 2021, so these numbers are from 2 years of full-time laboratory testing. Challenge with rollout. Switching our format required new pipettes for smaller volumes. We went from the biochemical methods using often 10 milliliter media tubes to using PCR tubes, which are less than 200 microliters. The lysate that you add is in 5 microliter aliquots. So our analysts had to learn PCR and molecular techniques to prevent cross-contamination. We've also moved from buying our media pre-made in polycarbonate bottles to a dry bag format that required reconstitution using a liquid handler. New software, which pretty much every new method you get, it required analysis from our QMS or quality management systems, our IS and cybersecurity teams. New reporting procedures and review procedures took some time to get used to. Confirmation procedures was challenging. It required us to go back to the enrichment broth, which we hadn't been saving in the past. So we used to be tossing the enrichment broth after the test was in its new biochemical reaction tube. However, now we needed to save it in case we needed to go back after the PCR test is done and return to the enrichment for further testing. We built in flexibility into these procedures to allow for a smoother transition. So now we allow that enriched media to be saved in the fridge for up to 24 hours, or an aliquot thereof that enrichment, which saves us space. Confirmations we allow to return to the lysate rather than the enrichment. And so the lysis step does not have to be repeated. All these steps were part of our internal verification, and we ensured that the assay maintained specificity and equivalent limit of detection with these small modifications. As it worked in our heads, in our methods prior to the incorporation of NutriPlex Pro, we would be spending about $15 a sample. This would be on 3 pathogen kits and an enrichment broth. This only worked in our heads because on paper, it didn't work. We wouldn't often use just the one enrichment broth, and we would often need to confirm presumptive positives, and our laboratory always performed investigations for other laboratories getting presumptive positives. This increased our actuals to 87% more than our theoreticals, and our testing cost was high. We needed to bring it down. 2 years after the implementation of NutriPlex Pro, we see much more closely aligned practiced and theoretical totals versus $13.50 versus $12.25. This brings our actual testing costs down to less than half of our older methods used. When extrapolating this across the year, we see savings in just our pathogen testings of upward of $123,000 a year. After we rolled it out to all Herbalife US laboratories, we see a cost savings of $450,000 a year. So almost $500,000. So this was our previous methodology. It's our 12-month rolling average overlaid with a 2-year average. And our new testing average is less than half of that. In addition to this, hands-on time, huge savings as well. I used timed methods from our microbiologists, and they were experienced microbiologists. I averaged those timed methods over a week and compared it to the time that they estimated those tests would take. In this case, they would start with 20 samples, time start to finish each major step of testing, which included sample preparation, transfers, equipment preparation, reporting. Dividing their average by 20 was a per sample result. Theoretically, that time is 10 minutes, what they assumed. In practice, they were able to excel and do it in 8.5 minutes. This is after each microbiologist with 2, 3, or 5 years of experience, depending on which microbiologist you tested. After we introduced the NutriPlex Pro assay, we performed the same experimentation after a month, and we witnessed a real-time savings of 2 minutes per sample. 2 years after that, we repeated this experiment just last month. We witnessed a real-time savings of 2 3/4 minutes per sample, and this saves us, with our sample volume, 700 personnel hours per year, which is a third of a person. This is good news too. We have real increased specificity here. This is the reduction in the confirmations which is required. So this graph shows the false positives that turned out to be true negatives. So there were actually false positives. We used to see about 7.3% of our samples presumptive positive for Staph aureus, 1.2% presumptive positive for E. coli. This is over the 2 years prior to the rollout of the NutriPlus Pro assay, so about 2019 through 2021. I mean, we rarely got a salmonella false positive. But after the rollout, we see significant reduction in our false positives that turn to be true negatives rate. And that is a 3.1% just E. coli. We don't see any false positives with Staph aureus, and we see no false positives with salmonella species. This reduces our false positive rate over 50%. And can be, it's highly attributed, or highly contributes to the cost savings that we see. And this is very important, talking about plastic waste. This is going to be our last section today. And I believe it's the responsibility of laboratories using single-use plastics to try to reduce that use as much as possible. Reduction of our environmental impact is very important to conservation. The biggest driver of this is our transition to the NutriPlus Pro assay and our change of media format. It required us to build trust in the use of less plastic. Today, I'm also going to discuss the purchased plastic reduction and then the waste reduction that we've seen. Plastic sterileware in the microbiology laboratory is single use. Plastic sterileware is often polycarbonate, scoops, spreaders, loops, petri dishes, and these things all come wrapped up in their own individual plastics as well that require that to ensure their sterility. We wanted to reduce the amount of plastic we used, not by reducing our use of sterileware, because we couldn't sacrifice sterility, but the number of times that we actually had to use those sterilewares. We would be able to, instead of using 3 methods to test for 3 pathogens, using 1 method to test for 3 pathogens, we could potentially reduce our sterileware use 3x. This removes the need. So the one universal method would remove repeat pipette steps. It would remove multiple enrichments and the vessels that they are enriched in. And actually moving to small format use less plastic as well. Instead of a 10 milliliter vial or test tube or like a 20 milliliter petri dish, now you're using a 200 microliter PCR tube. Physically less plastic being purchased and brought into the laboratory. Our successes in this case stemmed from a universal enrichment. We use now the multiplex enrichment media, and we co-enrich now Staph aureus, E. coli, and salmonella. It's sold in bag format, so we had to reconstitute it with a liquid handler, but we now use Whirl-Pak bags to dispense into, so that reduces our use of plastic bottles, these 100-gram polycarbonate bottles, and allowed us to do it 3 times over by using 1 method instead of 3. We already had a liquid handler. We decided to take a renewed look at our needs. Could we pre-fill a plastic bottle? What was the practicality of pre-filling bottles? But what's those costs on storage? What's the cost of the bottle? How much time does it take? We decided that it would be best to contemporaneously fill your vessel with your liquid enrichment media at the same time as you're putting your sample in. So that's our time savings right there. But we had to find something that was easy to do that in. The polycarbonate bottle wasn't exactly reasonable at that time, because the polycarbonate screw cap bottle was approximately 16 cubic feet of storage space for 500 bottles. We considered something along the lines of a solo cup, something that was stackable and rigid, but we can't ensure the sterility of a solo cup. There is no cap, there is no top. And at the same time, something along the lines of a solo cup, it doesn't save tons of space as compared to a polycarbonate bottle. We decided to move forward with the NASCO Whirl-Pak, so the Whirl-Pak stand-up bag. Because this bag allowed us to put sample in, dilute as necessary with our enrichment media, and then you whirl it to seal it and stick it in the incubator. It stands up, it's easy to ride on, and it fulfills all of our needs. So switching format was the biggest issue. Now we had to reconstitute the media bags instead of bottles. That presented a little bit of a challenge with trust in our laboratory. We wanted the microbiologists to truly trust that the plastic bag was going to have the same functionality as a plastic bottle was. We had to address those microbiologists' needs. What they need is something that doesn't spill and create messes for them. What they need is something that's sterile. What they need is something that seals easily. And for the first 2 months, we used something like binder clips to seal the tops of these, because those microbiologists didn't actually trust that this was going to be sealed. We used to use a screw cap bottle. That screw cap bottle often provided the assurance that we needed that nothing was going to spill out of it. We didn't feel that we had the same assurances with the Whirl-Pak stand-up bag, but these were challenges that weren't. The Whirl-Pak stand-up bags have never leaked in our laboratories. We continuously put them on trays just as a safety precaution, but to this day, we've never had a busted seal or a leaked bottom out of the Whirl-Pak stand-up bags as we initially thought we would. So we no longer use those binder clips either. We actually, we seal them up quick and stick them in the incubator. And this was the driver of our main plastic purchase reduction. So we would purchase the polycarbonate bottles, which is about 100 grams of plastic polycarbonate, instead of the Whirl-Pak bag, which is about 5 grams. So we were able to reduce our plastics, our sterile plasticware per sample by 125 grams. So theoretically, that led to a plastic purchase savings of 1 metric ton per year. In actuality, it was 2,500 kilograms, so 2.5 metric tons per year. That also reduces the methodology, actually reduced the amount of confirmations that we needed, and pipette tips were reduced. There were a lot of different reductions that led us to about 2.5 metric tons of plastic waste reduction, plastic use reduction. And plastic waste is another topic. Previously, using polycarbonate bottles, we would contract our biohazardous waste. In microbiology laboratory, anything that touches an enrichment broth for pathogens needs to be treated as biohazard. So when you contract out biohazardous waste, it gets disposed of, autoclaved off-site, and then it automatically goes to landfill. We were able to propose to another industry partner about a waste-to-energy solution, whereas we would now be able to autoclave our waste. Instead of the plastic bottle, now we can autoclave it ourselves, and we sell it to a waste-to-energy facility. Now, waste-to-energy doesn't necessarily sound great, But on the EPA's hierarchy of disposal methods for plastics, energy recovery via waste to energy is better than going to landfill. And what we've witnessed to date is approximately 2,500 pounds, 25,000 pounds, excuse me, of biohazardous waste that's no longer in landfill. It's been used for waste to energy over the last year. I want to thank you guys for having me. I want to thank Kristen for inviting me, and Midland for hosting.
Thank you, Chris. That was very informative. We did have a couple questions come through the chat box. The first one is Whirl-Pak sustainability study certified or have an ISO certification?
I'll take this one, Chris. Currently, Whirl-Pak had done a study through a third-party company, PTIS, and we're currently in the progress of getting a certification, ISO of 14040, so that we can help outfit and help labs audit in their conversion from bottles to bags.
Thank you. Another question, were there any hesitations from Chris in the conversion to bags or any issues with the team from launch to today?
Yeah, I think I touched on that just a little bit. We were initially concerned. You can't have the same rigidity in a plastic bag as you have in a plastic bottle. And in a laboratory environment, you would think that that is a little bit important before you have the experience with the plastic bag. What I touched on was just building a little bit of trust in the plastic bag that it's not going to leak, that it's not going to fall over. Is imperative, but we were able to gain that trust within a month of using them, and now we have no plans on going back to anything hard-sided in the future.
Outside of waste reduction, what are some time-saving examples?
Oh gosh, so new methodology, everything's streamlined. Previously, we would have had to do 3 sample preparations for 3 pathogens. One of those being E. coli, 10 grams of sample into an enrichment broth. For staph, you have to weigh another 10 grams into another enrichment broth. And for salmonella, you have to weigh 25 grams into another enrichment broth. Now you do it once with 25-gram analytical units. All of that just goes into the incubator as one pipette step out of the enrichment broth into a lysis tube, 1 pipette step per sample out of a lysis tube into a PCR tube, get it onto your equipment. And the whole thing is run by your LIMS software too, so you don't have to document or report hard copied if you didn't want to. There's the whole streamlined mechanism of the NutriPlex Pro assay really solves a lot of time issues in the laboratory.
Last question that I see here is where can I learn more about Whirl-Pak's products to aid in my conversion from bottles to bags?
Yeah, you could go ahead and visit whirl-pak.com, and on there we actually have a page dedicated to smarter sustainability. So within there you can find another video on Chris with a high-level view of how they converted from bottles to bags. Additionally, some of the metrics and data behind the sustainability in terms of waste reduction, water reduction, CO2 emissions reduction, as well as the products that can help make that conversion from bottles to bags. Yeah, so check it out. And then on there's a form, and you can go ahead and request more information or samples if you're interested in learning more.
Great, thank you. I don't see any more questions in the chat, so we can go ahead and end the discussion now, but thank you all for your time. And again, we will send out the recording of the presentation. Thank you, everyone.
Thank you. Thank you, Chris.
Thank you for having me.